Hello, now we're looking at question 7, the final question for your exam. All right, this is a very similar question, but please note that this is the easiest question. All we're doing is identifying features of this quadratic graph that we're given. The graph y equals x squared plus 2x minus 3. So this equation, called a parabola, is defined by this equation given to us here. All right, so now we want to be able to, now by the way, let's put the x-axis here, right? This is the x-axis, and this here is our y-axis, okay? And we want to do what? We want to determine first off, the x-intercepts. Where does the graph cut the x-axis? This horizontal axis, right here and right here. And those are x values, right? So we can put x equal 1 and x equal what? And x equal -3. Some persons tend to put the x-intercepts as points. So they would put the x coordinate being right here, right? The coordinates of the point. They may put the coordinates of this point, which is 1, 0. And the coordinates of this point, which is -3, 0. And that's fine. All right. Now the roots of the equation is the same thing as the x-intercepts. So we'll put that as x equal 1, x equal -3. And the y-intercept is right here, right? And we're going to use the y coordinate because this is actually, the y-intercept is found on the y-axis. That's where the graph, the green line they're seeing there, the green curve going all the way around, it cuts the y-axis at what? -3. So we can put y equals -3, okay? And again, if you want to put a point, put this as the coordinates of the y-intercept point, it's going to be 0, -3. When we talk about the intercepts, the other coordinate is always going to be 0. All right, so now let's look at the part D now. The coordinates of the minimum point. Where is the minimum point? Where is this graph a minimum? This graph is a minimum as its lowest point. So when going straight down, imagine this is like some kind of valley, right? How far down it goes? Right down to this tip right here called a turning point. And the turning point here is a minimum. That's the lowest point on the graph. All right, so this is our minimum point. And since it's a point, it has what? It has 2 coordinates. So if we want to find the coordinates of the minimum point, we go up first off, we want to go to the x-axis to get the x value, going straight up here. All right, because hits the x-axis at what? -1. So for the minimum point, all right, x is going to be, let me just write it somewhere else. Let's write it here. X is equal to -1. And the y coordinate, so we go across from the same minimum point right here, we go across to what? The y-axis. And it hits the y-axis at what? -4. So the y coordinate is -4. Very easy. Okay, so always go to the x first. Yes, you always have to write the x value first. And if you want to write it as a point, you're going to put it in the point form, as in on the ordered pair form. You put the x value first, which is -1. And then the y value after, which is -4. Always have to put the x, then the y. So either option is fine. All right, now E, the equation of the axis of symmetry. The equation of the axis of symmetry. Well, the equation of axis of symmetry, what is that exactly? If you look at this this parabola, where does it cut this parabola? Think of this parabola like the mouth of an alligator, or let's say maybe, right, the beak of a bird or something. Where would you cut it? So it's divided into 2 equal or congruent parts, or 2 equal halves. Now that you wouldn't cut it horizontally, right? You wouldn't get two equal halves, but you cut it vertically right along here. All right? It will always go through the turning point, whether to the maximum point, if the graph has a maximum point, or through the minimum point. In this case, that's a minimum, so it cuts right through the minimum point. And where it cuts through the minimum point, the x value is -1, right? So that's the equation we're going to write with x, the x value, x equal -1. So that's the final answer for the equation of axis symmetry is x equal -1. The x value, the vertical line that cuts through, right? That's the axis of symmetry, the vertical line that cuts through the parabola and divide it into 2 equal halves. By the way, there's a formula you can actually use to get the equation of the axis symmetry. It's actually x equal negative b over 2a. And so remember, we talked about the previous video, question 6. Now, the number before x squared, if we don't see it, there's a 1 there. All right, so this is actually y equal ax squared plus bx minus 3. Plus c. I was writing back the equation. All right, that's the equation, right, in the general form. Previously, we put equals here. Now we put y, okay? So now, if you look at this, the a value is what? The a value, if we equate the coefficients, the a value is 1. And the b value is what? The b value is 2. The equation for the axis symmetry, the formula does not utilize c. So we don't have to worry about the c value. So we're going to put, in place of the b, we're going to put the b value, which is going to be, all right, let's do that. The b value is 2. So we're going to put 2 where b is, divided by 2 times a. And the a value is what? 1. All right, so if we were to work that out now, all right, let's work that out. The negative of 2 is what? Negative 2. And 2 times 2 is what? 2. And 2 to 2 goes once. So it will be negative 1. So x equal negative 1. All right, which is exactly what we have down here. That's where the graph cuts through the parabola. All right, so you can use the algebra method to find the equation of axis symmetry, or you can just simply recognize where the graph cuts through the parabola, the drawn graph.